Okay. Can I get a thumbs up from someone on the back row to make sure that they can hear me back there? Fantastic, thank you very much. So I'd like to welcome you all to Debugging Tips and Tricks for .NET Developers with Visual Studio. My name's Casey Anderson. I'm a program manager. I work on the Visual Studio debugger. I've been at Microsoft for about 2 years now. Here's my email and here's my Twitter. Thank you for following me if you've done that already. Oh, those aren't my slides, these are. So, I've put a couple quotes up here on the board. And one of the reasons you guys might be here is because no one gets paid to debug code. You get paid to write code and you get paid to make it work. So when we talk about debugging tools are trying to help you improve your productivity. They're supposed to help you find and fix your issues faster, or as I like to call it, supercharging your debugging. So today we're going to tour the debugger, and we're going to go through 30+ tips and tricks about how to find and fix issues in your code using Visual Studio. And before we get started with the demos today, I just wanted to ask, because I'm curious, how many people have either been to a debugging tips and tricks session, seen one online by me, myself, Daniel Moth, or Andrew Hall? Go ahead and raise your hand. Okay, so that was about maybe 30, 40 people. So today, we're going to go through some of the content you may have seen before, but then at the very end, I'm going to show you 2 very new things that are in Visual Studio 15 Preview 4, and 3 sneak peeks at stuff that hasn't been released yet, but I'm going to show it to you anyway because I'm really excited about it. Sound good? Cool. So let's just jump right in and get started with our first demo. Can everyone see my screen okay? Another thumbs up from the back. I cranked up my font size, so hopefully it's good enough. Okay. So I have an application here, and you can see that it says, hello, provide conference argument. Well, like I said, debugging tips and tricks is popular. We give this talk all around the world, and because I obsess over my customers, I want to greet all of you personally and uniquely and individually. And I could go and edit the code by hand every time I change conferences, but instead, what I'm going to do is pass command line arguments into my WPF project here. So that's what this conference flag is for. So if I come over to my Solution Explorer, I can right-click on my project and go to Project Properties. The project properties has this special debug tab, and in here there's a bunch of various options. So you can start this project, which is what we have set, or you can start an external program. So for example, if you deal with Office extensions, you can set your startup program to be something like Excel, and then when that calls into your maybe library code, that will trigger debugging to start. Here's where I can pass in my command line arguments, and I can also enable different debuggers. So I can enable the native debugger to do mixed mode, and also enable or disable the Visual Studio hosting process, which is just supposed to help give you a performance improvement when you're going through that F5 cycle. So the command line argument that I wanted to pass in was conference, and who are you guys? You are my Ignite peeps. Yeah, you are. And I'll just go ahead and save this. And so when we start the application again, I'm going to expect it to say, hello, Ignite peeps. Wah, wah, it doesn't. It actually says hello, conference. So this is a bug, and I'm going to try to figure out what's going on. Clearly, this is in the startup path of my code. And I don't have any files open here. Maybe I don't exactly know where my startup path is. Did you know that you can use F10 or F11 to step into your code and start debugging? So right here, I'm just going to use F11 and step into, and that lands me at the first line, the entry point to my code. And now I see where I am, and I can start stepping over. So as I go through this, I see I initialize my component. I'm looking at my string provider. I've got my view model. Oh, here's where my greeting gets set. And when I hover over my greeting, it says hello, conference. And I can see that I'm doing a bunch of different method calls and concatenate them to get my greeting. Well, how do I know what the issue is, where things are going wrong? If you come down to the locals or the watch window, you can see the return values of method calls as you step over them. I know I run into this a lot where I'll hover over this and I'll be like, oh, I just want to see what that returned. Well, you can. If you go to the watch window, we added return values down here. So I can see that get greeting returned hello and get conference returned conference. And if I am used to the watch windows, I can use $, return value, and the number, and that will show me the return value of that thing. So this is return value 1, and I can do return value 2, for example, and it's return value n. And so this will show me hello, for example. Looking at this, I can see that it's really my getConference function that's returning the wrong thing. So I want to go and step into that. And I could restart and rerun my application, because this is in the startup path. But instead, I'm going to use a feature called setNextStatement. And some people use this by dragging the instruction pointer, but you can also right-click on the line of code that you want to tell the debugger to execute next. So I right-clicked on line 200. I'm going to come down to the context menu and do setNextStatement. I can also drag my instruction pointer up. So now this is the next statement that the debugger will execute. This doesn't unwind your code or reverse any calls that you've made. For example, you can see that getGreeting still has a value here. So this can cause side effects, and you want to be careful when you do it. But in this situation, I know that this is a safe operation to do, because I'm just concatenating the string. So now, when I am on this line, getConference was my issue. I really want to step into getConference. There are a couple ways I could do this that take a little bit of time. I could F12 on getConference, set a breakpoint, hit continue. I could step into, which would land me in getGreeting first, and then I'd have to step over getGreeting, and then step back, and then step into getConference. But there's a really great shortcut that's available in the context menu of the debugger. When I right-click on this line, you can see this step into specific right here. And this shows me all of the available functions on this line that I can step directly into. So for example, getConference right here, as soon as I click on this, it's going to execute my code until I stop at the first line of getConference. So it does call getGreeting first. And it lands me here in getConference. And as I look through getConference, I want to come down here so I can inspect some variables and run down here to see what's happening with my args. Well, again, I could set a breakpoint in F5 to this line, or I could step, 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 and I'd have to step through each part of my for loop. But there's another great feature that saves you time called run to cursor. When I right-click in that same context menu, you can see it says run to cursor. And so this isn't like setNextStatement. It doesn't skip over the code, but it executes until that line is hit. It's like a temporary breakpoint. Run to cursor. OK, so you can see that it stopped on that line. So this run to cursor feature, there will be a quiz later on that. So keep that in mind. OK. Now, after I've done my run to cursor, I can come in here and I can look at my args. And I see that conference is the first argument and ignite peeps is the second argument. But right here, I'm only returning conference, and I really want to return the second argument. So using another feature called edit and continue, I'm going to go ahead and while under the debugger, add a +1 here in my code. You can see that I've made this code change, and I can save it doing Control-S. And I don't have to stop and restart the debugger to make simple edits like this. And that saves me time, because sometimes it takes a while to get things going again. So now that I've made that edit and continue, I can go ahead and step out of this function and go back to the line that I came from, which is right here. So I made that edit. It got called in getConference. So when I step now, where do you think I'm going to step? I'm going to step into getPunctuation. And if I keep stepping into getPunctuation, I step into getExclamation, and now I'm down here 3 layers deep in my call stack. I want to show you that run to cursor feature again, but this time I'm going to use it from the call stack. So sometimes when you're inspecting code, you go in. You could be 7, 8, 10 layers deep. And instead of having to step out every time, it kind of gets a little exhausting once you find the issue that you think you have found, you can right-click on the call stack and use the run to cursor feature here. And what this is going to do, it's going to step out of each of those functions and stop you on the line of the call stack that you want to step out to. So I don't have to step out here, and it takes me back up to this line. And when I step over it, you can see that it executed getPunctuation. It stepped me right back out, and now I'm in the rest of my, I can continue the rest of my debugging. So as I continue, you can see that I fixed my issue using edit and continue, and now I'm greeting you personally. Hello, Ignite peeps. Hello. Thank you. I appreciate that. I know you guys just finished your box lunches and the room's a little dark, so I hope I keep you awake and we don't get some dozers. So, I wanted to show you. One of my favorite things that you can do from Visual Studio, a lot of people don't know about. I'm going to go ahead and stop debugging for a second and pull up my immediate window. If you haven't seen the immediate window before, it's kind of like, maybe you've heard of the interactive window. It's a place where you can go and you can type code, you can build up state, you can set up variables, or while you're debugging, you can change variables, which I'll show you later. But for now, I'm in design mode, and a lot of people don't really realize that you can use the immediate window during design time. So right here, I'm not running the debugger, but I'm going to set up string A, and I'm going to have it be Marco. And now I'm going to set up string B. And what should string B be? Polo. Good job, guys. Exactly. So now I can show you that in the immediate window, A is Marco and B is Polo. Thanks, guys. OK. So now I'm working on, let's say I'm working on a library function. So in this instance, I have this string utilities class, and I'm working on my reverse string function. And what I want to do is I'm having an issue, and I want to test it out, for example. So right here in the immediate window, without having to set up like even like a test harness or even like a main console, new console application just to test out my library code, I can do that directly from the immediate window. And when I execute this, you'll notice that I hit a breakpoint. So the immediate window, it's kind of running the debugger under the covers. And so when you hit a breakpoint from the immediate window, you actually stop on that breakpoint, and you can inspect variables and inspect the state of the application at that time. But I set up two strings here. So it also supports nested breakpoints. So now for string B, I've hit string B. And in the call stack window, you can see that I have these nested breakpoints. So it supports that. And when I hit continue now, it's going to continue and reverse Polo. So it's OLOP. And if we see the call stack, you can see that breakpoint. There's only one on the call stack now. And when I hit continue again, it'll reverse Marco. And so it's Okram. So Okram, Oblop. OK. So you can use the immediate window during design time. Let's do a quick recap of all those things we talked about in the first demo. And we're going to do that for about 60 more minutes. Everyone up for that? Woo! OK. That was a little loud, sorry. Great. So I'll move on to my second demo. OK, we're back in Visual Studio. I'm going to go ahead and pull my application up. So what this application is I'm kind of working on something with my coworkers. We're trying to create like a repository and a list of all the applications that we have available to demo at conferences and things. And right now, we're building this up. And what I want to test is the loading of my data. So I just want to make sure my data is going to be loaded properly. And eventually, I want to connect this to a web service to get the real info. But now, I just want to see how my data is loading. So I'm going to click the Load Data button. And I am stopped in the debugger. And this isn't because I have a breakpoint set. As you can see, there's no little red dot here. It's because I hit a debugger.break. So that's another tip you can use, is you can use debugger.break inside your code and as kind of a hard-coded breakpoint. So when the debugger, and you can see that I've wrapped that in a debugger.isAttached. So what debugger.break does is it's essentially throwing an exception under your code. And when it's not wrapped in debugger.isAttached, if your code is executing, it'll crash your application. But if you have it in debugger.isAttached, when you do the release version of your code, the debugger's not attached, so your application's fine. And debugger.break is, like I said, a great hard-coded breakpoint. If there's perhaps a really tricky execution path and you want to make sure, oh, every time that gets hit, I really want to stop here to inspect what's going on, debugger.break is great for that. And you can also use debugger.isAttached in like an if statement like this for different things. So if you want to force your application to behave a different way under the debugger, maybe force some variables to be something specific, but you really want to safeguard that that doesn't happen during release time, you can use if debugger.isAttached for that purpose. Cool. OK, so back to inspecting the loading of my data. here I can see my data provider, and it has a bunch of different data in it. All of this data kind of looks hard to read from this data tip. So I have this magnifying glass next to some of these variables, and what I can do is click on the magnifying glass to see a list of available visualizers. So we have 6 visualizers that are supported in the debugger, and I'll show you the text visualizer first. All this does is open a window that will show you the entirety of that text. And you can copy and paste from here, and you can wrap or unwrap. And this is just a quick and easy way to remember or to help you see those long data tips that you may not be able to. And you don't have to select every time. The visualizer remembers the last visualizer you click. So now when I just click the magnifying glass, the text visualizer will come up. The other type of visualizers we have are the JSON visualizer. And this allows you to, like it implies, visualize your JSON data. The coolest part about this for me is that you can search. So if I want to search my JSON data for app ID, and see what all of the app IDs are here, I can search this visualizer for that and see my data structure. What other visualizers do we got going on? We got the XML visualizer. I'll show you that it just renders your XML here. HTML visualizer does the same for HTML. And last in this little area is the dataset visualizer. So the dataset visualizer will show you all of your tables with rows and columns, and it's a really easy and convenient way to make sense of what's going on in your data set. And so that's 5 visualizers if you've been counting, and I mentioned that we have 6. So the 6th one is actually here. I can see it in the locals window for this object, which is my main window. So it's the WPF tree visualizer. If you're using Visual Studio 2015, you might be familiar with the XAML Live Visual Tree. This is just the tree visualizer that you can interact with while you're debugging and stopped at the debugger. So I can click in and see what the different properties are for the different layers of my WPF application here. Cool. Can you see, not with the WPF visualizer? So yes, I think there is. It's not built into Visual Studio, but I should mention that the visualizers are an extensibility point. So there are visualizers available on the gallery that you can download, and you can create a custom visualizer. If you don't find what you're looking for, or the visualizer isn't giving you what you want, there are docs on MSDN where you can create custom visualizers to display whatever object type you need to. Sorry, does that kind of help? Okay, great. Cool. Okay, so now that I've verified that my data is loading the way I think it should, I'm going to look at my app list here. And I see I have 25 apps, and they're all of type app info. When I look at this array, I'm sure we all do this all the time. You have an array of objects, and you're like, oh, man, I have to drill down inside each of these objects just to see the thing that's relevant to me, the thing that I know that object by. Well, that can get kind of frustrating. So I'm going to show you how to use a debugger display attribute to change how you can see those things inside the watch windows and data tips. So app info is the type, the object type. I'm going to use peak definition, which is Control F12. Nope, that's a lie. It's Alt F12. Go back. Alt F12 to peak the definition of app info. And so this just opens up that peak window so I don't have to shift files. And right above this class, I'm going to add the debugger display attribute. And you can see that it's not, IntelliSense isn't colorizing it. So I'm going to use control dot, and control dot brings up the light bulb, and I'm going to go ahead and include my using system.diagnostics there. So light bulb was an easy way to help me fix that. And I'm now going to tell the debugger what I want this to display as. So I'm going to tell it to tell me my app and my app ID. So I actually want it to print out the value of my app ID. I'm going to do this using curly braces. So inside the curly braces here, I'm going to type app ID. Oh, now I can't remember, is the D uppercase or lowercase? Well, it's hidden behind my data tip here. So I'm going to hold the control key, and you can see that the data tip fades out. So this works for data tips, for tool tips, anything that you're hovering over. When you hold the control key, you can like peek behind it and see what's up. So I can see here that my ID is capitalized, so I can finish this out just dandy. And you'll notice this purple squiggle means that I've made a change that I can't use edit and continue for. So I'm going to have to restart the debugger to have this change applied, but that's OK. I can go ahead and close this window. So now when I hit my breakpoint for load data, and I look at my list of apps, I still see I have 25 apps, but now I have a handle on what those apps are, which app is which. One thing about the debugger display attribute is that the debugger will first look for toString. So if you've implemented toString on your class, the debugger shows that first. And then we look for debugger display. And then if we don't find that, we default to the object type. Cool. Cool. OK, we're talking about data. So let's talk about everyone's favorite way to look at data, the data tip. So I'm going to come down here and hit this breakpoint. And this is a for each loop. We all have loops in our code all the time. I see people so often, hit this breakpoint, look at the app. Hit this breakpoint, look at the app. Hit this breakpoint, look at the app. Well, what if I told you that there's this handy-dandy little pin icon right next to every one of your data tips that you may never have seen before? And when I click on this pin, it creates this pin data tip right in my code in line next to the value. So now, as I hit that breakpoint again, boom, I can see in line the value of that object. And you can also expand down and even add something. So if I'm interested in the display language, for example, I can go ahead and, that's the wrong one. But I can go ahead and add an expression. So here I can type display language. That's wrong. Kind of going off script, guys. But I can do this, I promise, if I can remember how display language is. Display language. Oh, display languages. Thank you, guys. Display languages. You're perfectly right. See, this is why I shouldn't go off script. But you guys know how to program. There we go, app.displayLanguages. So I can add things. So this can become kind of like my transient app window, or transient watch window right here. And as I continue through, again, I can see when things are changing and what they are. So that's how you pin them. And that's what pinning's good for in loops. Now, let's say I am really interested in app 4 right here, and I want to maybe compare that to a different app through my loop. How am I going to do that? Because as soon as I step into get languages for display, for example, app, the name is no longer within the local scope, so that gets grayed out. Well, I'm going to tell you about make object ID. Has anyone here ever used make object ID before? Like 4 people. OK. So make object ID, I find it really handy when you want to keep track of like a particular object as you're going through different parts of your code. So I right-clicked and selected make object ID. And you can see it has this little handle here, $1. And I'll show you in my watch window that I can refer to this object now as $1. And that's showing me the value, because the object exists in memory, even if app goes out of scope. So I'm going to go ahead and step into get languages for display, so you can see how this works here. So I can't find the values of app 4 anymore. This isn't in scope, but I can still access it here. So make object ID is a really convenient way to keep track of objects as you go through. And now when I hit this breakpoint again, and my app has changed, my the $1 object is still around that I can refer to and maybe compare against. Now, there is a small memory cost and overhead of maintaining these object IDs. So when you're done with it, I recommend going ahead and clearing that up by deleting your object ID. So we'll go ahead and delete my object ID. Thank you. Yep, and then so I deleted my object ID, and I can just delete them from my watch window. Cool. And so that's what I got for you for showing your data values and how to inspect data. Here's a recap of that. Hope that was somewhat helpful. Yes? So the question was, if you just delete it out of the watch window without explicitly deleting object ID, does it hang around? And the answer is yes. So unless you explicitly delete the object ID, it will still hang around. And we do that so you can get a handle on it later if you need to. OK, so I'm going to set up just my next little bit here while you're reviewing the content on the screen. Yeah? No. So they just exist for the one debugging session. Yes. So the question was, do those handles get deleted after the debugging session is over? And that is correct. So if you try to reference $1, like after I restart my debugging session, it won't give me any value. Cool. OK. So now that my data's loading, I want to run my tests. And I foobarred. I see that my web test passed and my mobile test passed, but my desktop test is failing. I hate it when I fail. So I want to debug this issue and figure out what's going on. I have an inkling that something is happening right here in my app data provider. And right here, I'm looking at my application set and trying to return the list of apps by type. So I'm going to hit this breakpoint by running my tests again. And I can see my decoded type is web. Well, what test was failing? Desktop. So I'm really only interested in when the decoded type equals desktop. So I could sit at this breakpoint and continue until I get to a desktop. But instead, I can also set a conditional breakpoint here. So in 2015, we introduced this breakpoint settings toolbar. And when you click on the gear icon, it opens this inline breakpoint settings window. And you can add conditions or actions to your breakpoint. In the conditional expression field, you can write anything that evaluates to a Boolean expression. So in this case, I'm interested when decoded type, and you can see I get IntelliSense here too, which is new in 2015. So I can see that decoded type equals desktop is the condition I want to check for. And I can just hit enter, enter, close this, save, continue. I don't have to deal with modal dialogues anymore. The other conditions that we support are hit count and filter. I'll talk about filter a little later when we touch on some multi-threaded debugging tips and tricks. And hit count is great for when you're debugging through like giant loops and you know the problem happens on the 105th iteration of the loop. You don't have to hit that breakpoint 105 times. You can just set a hit count breakpoint and get right there. And the other part of this is actions. So when I create actions, this is known as a trace point. Has anyone here used a trace point before? Oh, only about 4 or 5 hands. So what a trace point does is, who here has used like console.writeline, debug.writeline? Way more people, exactly. Well, when you do that, you actually have to edit your code, and there's some overhead to going back and deleting those things again. Well, with the trace point, we're basically doing that for you. So I can put inside here plain text, and that'll get printed just as plain text. I can use my curly brace trick again to get like object values, and so I can print out what the decoded type is. Oops, sorry guys. I can print out what the decoded type is using curly braces, and I could print out different things. Whatever inside curly braces gets evaluated. And then the last thing you can do is use the $sign to access this rich supply of pseudo variables that we have. So you can print the call stack, you can print the function, you can print the process name or the process ID. And so like if I use $sign function here, it would go ahead and print out the function where this breakpoint was hit. Now, you might be thinking, oh, but I'm still going to stop at that breakpoint. That's not true. We have this thing that's called continue execution. So if I uncheck this, I would stop at this breakpoint on this condition, and this would be printed to the output window. But when continue execution is there, no matter how many times this hits in this loop, it's going to print to the output window every time. And if you have IntelliTrace, which is an enterprise feature that we'll talk about in a minute, your trace points get recorded in the IntelliTrace window, so you can filter by them and just see all your trace points that way. So I recommend looking into trace points if you haven't seen those before. So now that I have my conditions set up where decoded type equals desktop, I'm going to go ahead and hit this. Oh, I'm already at the breakpoint. Yep, so I'm stopped here. Decoded type is web. When I hit continue, decoded type equals desktop. And I'm going to come down to my immediate window and see what's going on. So we'll clear out what I was doing before. And what I want to check is, are there actually items of type desktop inside my applications here? Well, I can check that using a Lambda expression. So data.applications.select a in boop, boop, a.apptype. And I can dump this to a distinct list. And in previous versions of Visual Studio, for example, Visual Studio 2013 or previous, and I'm using 2015 now, you wouldn't be able to evaluate this Lambda query. You would just get expression cannot be evaluated, and you'd be like, oh, again? But now, in 2015, Lambda expressions can be evaluated in the immediate and the watch windows. And I can see here, now that I've evaluated this in the immediate window, it shows desktop. So I do have objects of type desktop. So what's happening? Well, I'm kind of clued in. This desktop is with a capital D. This desktop is with a lowercase d. Could it really be that simple that I forgot to ignore case? Well, let's find out. I can use the immediate window as a kind of scratch pad to verify my assumption about this and test it without even having to change my code. So if let's see, if I add a string comparison, ordinal ignore case here, and then let's just say I take account of this. It's going to have applications. Whereas before, if I took account of it, it's got to be a capital, I had 0 applications. So yeah, I just use my immediate window to verify that it really is that simple. I just need to add this string comparison .ordinal ignore case to my code. And I'm going to use edit and continue again to add that up here. So now that I have that, and I'm getting an error because I have one too many curly braces, I'm going to unset my breakpoint and hit continue. And what happens is my desktop test passed. Woohoo! I always like to celebrate when tests are passing. Whew. Now that my tests are passing, I'm going to move on to what I'm going to do next, which is just getting all my apps, looking at that list from the server. Whoop, get apps. OK. So when I click get apps, you can see that it says an error occurred contacting the server. And I'm realizing what I forgot to do was start my web service. So I could right-click here on my web project and go debug start new instance. You might have done that before. But instead, what I'm going to do is click on my Solution Explorer and go to the properties. And I can set multiple startup projects from the Solution Explorer properties. So I'm going to start my web service without debugging and my WPF app with debugging. And I'm going to go ahead and apply those. Hit OK. And restart using the restart button. And now when I hit get apps, it'll show me my entire list of apps. So there we go. So that's how you can use multiple project launch to set up multiple startup projects. And let's see here. What apps of type mobile do I have? Do you guys see that flashing? This feels a little slow. Get apps is almost instant, but this load seems to take a while. That's a perf issue I kind of want to investigate. So let's see what's going on. I'm going to come down to my load by type click, which is where I know this is where something's going on. I'm going to set my breakpoint and hit that again. OK, now I'm at my breakpoint. When I take a step, I want you to notice this little adornment in the editor right here. It's called a perf tip. So perf tips show up when you hit breakpoints or you step. And what the perf tip is it's an order of approximation measurement of how long your code took to execute from the last step or the last breakpoint that was hit. So for example, like I said, it's order of approximation. So this says 1 millisecond. You know, the difference between 1 millisecond and 2 milliseconds doesn't mean that the 2 millisecond line of code was 2 times slower. It just means that, you know, the difference between 1 millisecond and 50 milliseconds, 1 millisecond and 500 milliseconds, those things are significant. So perf tips are actually pretty accurate on Windows 10. We did some work with Windows to get those more accurate. And I'll show you that they can work from breakpoint to breakpoint too. So I'm stopped here, and let's say I want to see how long it takes to execute this entire method. I'm going to set a breakpoint at the end of the method. And when I hit this breakpoint, it's going to tell me that this whole method took 602 milliseconds to execute. And if I'm not convinced that number is accurate, I can use setNextStatement, drag my instruction pointer back up, and time my method again. And I can see it took 653 milliseconds this time. So like I said, that order of approximation. And then if I'm like, oh, that's too slow, I can step through each line of code to see where exactly that time is being spent. So I get 1 millisecond there, 1 millisecond there. When I step over this call, 609 milliseconds. I am immediately clued in that this is probably where my issue is. So I can come back here, step into that, and see what's happening. Well, we've clicked load by type a couple times, and so this server certificate, I would expect it to be cached, which is what I'm trying to do here with my certificate store. And as I step through, I see that I'm not, it hasn't been cached before. It's not going into this part here. And now that I look at the bottom of the code, what I'm realizing is I never actually added it to my certificate store. So I'm going to add that piece of code using edit and continue again, certificate store.add. And I'm going to add it by the base URL and the server cert. OK, so now when I use edit and continue to step out of this function and go back, I'm back at this line. Like this, so this is how long it took me to get back to that step, because I was adding my certificate to the store. Now when I run this function from breakpoint to breakpoint again, I expect it to be much faster. And I can verify using the perf tip that it is. So before, where it took 600 milliseconds, now it's only taking 10. So I did that. I diagnosed a performance problem just while debugging and stepping through my code. There's also a little trick about perf tips is that you see when I hover over it, it becomes a blue hyperlink. Well, when you click on it, it opens the diagnostic tools window. Raise your hand if you have used the diagnostic tools window before or seen it before. OK, more people have seen it. How many have closed the diagnostic tools window before? OK, quite a bit of people. That's just a little joke I like to make. And I like to tell people, well, the perf tip's there always. So if you ever want it back, just click on the perf tip. It opens right up. I like keeping the diagnostic tools window open because you can see in here that it has our events track. These are the break events. So it tells me what steps and breakpoints I've hit. And if you have Enterprise, it'll show you your IntelliTrace events, which I'll talk about here in a minute. But it also shows the process memory and CPU as it ticks along while you're debugging. So, for example, if you see a giant spike in CPU while you're debugging, that could clue you in that something's going on. Or if you start to see your memory constantly uptick, that could clue you in that you might have something going on with your memory that you need to investigate. So we're trying to move some of those profiling and performance issues that you really needed an expert for once the product ships a little bit upstream, so you can find and fix those issues faster as you're building your code, as you're debugging through just random places. We also have a tab that corresponds to each of these tracks. So I'll show you that in the memory usage tab, you can take a snapshot. And then you can take a snapshot at breakpoint. You can take a snapshot while your code is running. You can take as many snapshots as you need to. And when I take another snapshot, I didn't change anything, so it won't be here. But this is a diff of the difference in memory between the first snapshot and the second snapshot. And when you click on one of these, you can go into a more detailed view there. Then we have CPU usage. The profiler is disabled by default, but anytime you need it, you can just click this button to enable it and turn it on. And then when you run your code, so for example, if I get, oh, I'm stopped at a breakpoint. If I run my code again, you can see that I've started to capture CPU information, and I can get a call tree prepared for that time that I was profiling. And it'll show me the call tree right here. Sorry, the screen's a little small, or I'd make this bigger. OK, so that's CPU and memory. Let's go back and recap what we just talked about before moving on to some other fun things. Conditional breakpoints, lambda debugging, diagnostic tools, and memory and CPU. And what did I mention? IntelliTrace. Right, so let's talk about IntelliTrace a little bit. Sorry if that wasn't up long enough. The slides are all online. OK, so I am going to unset these breakpoints here. In my application, I'm going to click the error button. And when the error button gets clicked, guess what? An error occurred. Go figure. Well, because I have IntelliTrace, I'm starting to see something over here in my IntelliTrace events track. Every time I click this error, a red diamond appears. Well, what's that red diamond? It's actually an exception event that IntelliTrace is logging for you. So if I go here and to my events tab, I can see an exception's being thrown and an exception's being caught. So instantly, by just monitoring this, I can see that something's going wrong. And I can use historical debugging with IntelliTrace, meaning that I can look at this exception event and go back in time to the place in code where it was thrown. So if I click Activate Historical Debugging, which is that link on the bottom, you can see that I've got a yellow bar here that tells me that I'm in a historical mode. And I've got some windows that participate. This shows me the historical call stack and the historical autos that were collected at this time, so I can see the exception message that was thrown here. And the most important thing is that it shows me the line of code where that exception occurred. So I can go ahead and debug that issue. And I can hit continue twice to go back to live debugging after I've used IntelliTrace. Well, I know not everyone has enterprise. So how would you diagnose or debug an issue with exceptions like that if you didn't have IntelliTrace? You can use the exception settings window to turn on exceptions to break when thrown. So in previous versions of Visual Studio, this window used to be a big modal dialog that took about 6 seconds to open. But in 2015, we made it into this lightweight, non-modal tool window with a respectable search. So I can quickly search for things and figure out what exceptions I want to turn on, meaning basically set an exception breakpoint. So I'm going to check this box next to all CLR exceptions, common language runtime, those are your .NET exceptions. And when I check this top level box, I'm telling the debugger to break whenever those exceptions are thrown. So now when I click the error button and that exception gets thrown, you can see that the web exception occurred, and you can see what it is. And this is the same line of code that IntelliTrace has taken me to. So those are two different ways to kind of solve the same problem using the exception settings window. And I'll just also point out this exception settings window is quite huge and taking over half my screen, and the only parts I care about are basically the message and the information. So just keep that in your mind when I show you things that are happening secretly later. OK, cool. But while I'm here, though, I want to point out the call stack for a second. So I'm inside of an async task method. And you can't really see this call stack so good. I'm going to use another trick called full screen. So like we have design time and debug time, we also have full screen mode. You may never have used this before, but it just remembers a different layout for you. So I set up this layout ahead of time to show you the call stack on the right, so I can just go full screen mode and get a new layout that I can see. And right here, I've got my logical call stack. So I'll point out here that this says async call, async call. So this is something we added to help basically stitch the logical call stack together for you so you can make better sense of what's happening with your tasks. You can also see these external code nodes in here, And if you want to, you can right-click on the call stack and show external code. Prepare yourselves. Ugh, look at all that goop. So that's why we have show external code hidden by default, and especially if you have just my code turned on. But if there are instances where you want to dig in and see what that is, you just can right-click on the call stack and look at it from there. But that's a bunch of goop that I'm going to turn off for now. The other cool thing that not a lot of people know you can do with the call stack is you can turn on show parameter values. So when I do this, you can see that it shows me my parameter values in line. So as I'm stepping through my code, I can see what those parameters are being passed through my call stack. And there is some performance overhead for maintaining those. So if things are starting to get slow, I recommend maybe turning that back off. Yeah, so those are some tips for the call stack that you can use. And there's other things in here that you can turn off if your call stack's too big. You can turn off the module names or even the parameter names if that helps you figure out your issues better. And when I'm done with full screen mode, all I have to do is click this button right here to turn off my full screen mode. Cool. So let's go back to my slides and do a little review. What did we just see? IntelliTrace, exception settings, the call stack window, async calls, parameter values. OK, so I have 2 more demos to do. We've got about 30 minutes left. I've got plenty of time for questions. Does anyone have a question that they're itching to ask right now? His question was, in the exception settings window, how do you get the third-party exceptions? Yes. So when you can add them yourself. So if you know what exception type you need to add, you can go ahead and add that. But for example, like Python exceptions or JavaScript exceptions, when you have those runtimes installed, the exceptions will show up automatically in the exception settings window. So I don't kind of know which way you're going. Like if you have custom exceptions from your third-party library that are .NET exceptions, you can manually add those. I can go back and show you where that button is. But you can manually add those. Does that kind of help? Cool. So I'll just show you right here. You can add a custom exception. So custom exception, enter, and it checks it by default and adds it to the list to break. Any other questions right now? Yes?
Use the words, just click this button. I couldn't see which button you clicked.
OK, sorry, my bad. For adding the exception, on the toolbar, there's this tiny plus button. Ah, thank you. So view, full screen. On the top toolbar here, next to the help menu, there is the full screen toggle. And that's how you can exit out of that. No problem. Any other questions right now? That's OK. Are we having a good time? Yeah? OK, good enough. That's enough enthusiasm for me. I've got enough enthusiasm to carry us all through. You laugh. That makes me think so. Yeah, Joe?
Any of these characteristics have to be enabled before you can use them, or are they just when you install Visual Studio, they're just all of the IntelliTrace capabilities they already pre-enabled?
So the question was, do any of these capabilities need to be enabled when you install Visual Studio, or are they all pre-enabled? And so everything I've shown you so far is pre-enabled, so it's on by default. And with the caveat that I'll show you for IntelliTrace specifically, if you go to the debug options, IntelliTrace has its own menu, and it's on by default, but you can also take it up a notch to collect events and call information. So if you're using IntelliTrace, this will give you more variable values. Yes? Yes, IntelliTrace is an enterprise feature. Yes. Did that answer your question? Cool. And we got one more in the back there. Yeah. His question was, in the call stack, when it shows the parameter values, what does it appear like if it's a complex object? You know, off the top of my head, I don't know what type of complex object you're thinking about, but it will appear probably how we show it in a data type. So if you use the toString, it'll probably appear as a toString. If you use the display attribute, that's how we'll wire it up. So otherwise, it might just show the object type. Maybe one more question, or not. We can keep going. Multi-threaded debugging is next. Who here wants to hear about tips and tricks for multi-threaded debugging? Yeah, good deal. Let's get on with it. OK. Yeah. So honestly, multi-threaded debugging is something I get asked about at conferences all the time, just because it doesn't seem like there's a very cohesive story around it. Well, we actually have great tools in Visual Studio to help figure out multi-threaded issues that you may not know about. So I'm going to get this application up and running again. And I have this button called par. And what it's going to do is basically I'm calculating primes. And I can calculate my primes here from 0 to 500 and hit enter to calculate these things. Oh, and those numbers are tiny. You can't see those. OK, but it's calculating my primes, and it's doing this in parallel. So here's my bug. As I look through this list, I'm seeing the number 25 here. So while I might think 25 is the prime of my life, it is definitely not a prime number. So something's wrong in my logic here. Let's go. What? Very, thanks, guys. OK, so I'll go to my number utilities here and show you what I'm doing to calculate these in parallel. I'm just using the standard array.as parallel. Prime numbers lend themselves well. I can do a bunch of things. I'm letting something else schedule them. And I'm just going to set a breakpoint here and stop on my breakpoint. So calculate these things again. Where should I start? OK, let's start with the parallel stacks window. If I go to debug windows, scroll up, debug windows, we've got the parallel stacks window. When I open this up, it shows me the threads and their path through the code. So when I hit continue again, you can see that there are 7 threads in external code, 3 threads over here in isPrime, and I can hover over this and see which threads are in this isPrime function right now. And yeah, now I got to it. So even if, since I'm not scheduling these myself, you can see that this one took a different code path, but it's still in isPrime, and these 3 threads over here took this code path. So the parallel stacks window is a convenient way to see what the path of your parallel code is running. And if you're using tasks, which I'm not in this case, but you can also switch it to the tasks view. So that's parallel stacks window. And sometimes this can get quite big, so we have this convenient little navigator down here to help you out. The next thing I want to show you is the parallel watch window. We've got 4 parallel watch windows, just like we have 4 watch windows. But down here, I've already added this candidate field. But I can add another watch, like if I want to watch I, for example. I can see now that this watch variable is over each of these threads. So for example, since my candidate is 13, 11, 7, and 5, when I hit continue again, those numbers are going to change. And so I can use the parallel watch window. A lot of people use the parallel watch window for recursive values because it will show you the recursive steps. A lot of people don't know that you can use it to show you the value on each thread of a specific variable. OK, so as I keep coming through here, I can see that one of my threads got to 25, which shouldn't be the case. That shouldn't be happening. We're going to try this and hope it works. I'm actually going to right-click on this thread, and I'm going to freeze it, because that's the thread I'm interested in. And so what freezing the thread does is that means I'm going to basically put a little lock on that, and the debugger is not going to progress that thread past the point it's at right now. And if I go to my threads window up here, you can see the list of debug Windows threads. You can see the list of all available threads in your process. The yellow instruction pointer will tell you where the thread you're currently stopped on. So I'm stopped on this thread, so if I hover over candidate, it's 23 right now. So I'm not on this thread. And when I hit continue, it's going to, because this is the only thread that's paused, it's going to run all the other threads. And when I hit my breakpoint, you can see that it's going to run all my other threads. So now, when I come back here and async break all, you can see that this thread is still frozen, but the others kept running. So that's one tip, is that you can use, you can use that. OK, so now that I've frozen that thread, I want to thaw that thread and I have to be in a break state to thaw my thread. Okay, right-click, thaw. Thaw is the opposite of freeze. I know that makes a lot of sense, right? It's not unfreeze, it's thaw. So now that that thread is allowed to run, and I have a breakpoint down here, I'm hoping that that breakpoint is going to be hit. And it is. And I can see that candidate is 25. So the rest of my threads kept running, candidate didn't. And now when I step through here, I'm stepping through when candidate is 25. So I'll talk about that in 1 second. Okay, so I can see that it's not returning false. One of the big questions that we often get is, when I'm doing multi-threaded debugging, when I hit a breakpoint and take a step, it doesn't ever finish on that step. Has anyone had that issue where they end up on a different thread that they feel like? Yeah. So the explanation for what's happening there is that the debugger will always complete the step that it started on unless a breakpoint is hit or you've already stopped on a different thread. I know that's complicated, so I'll just go through an example real quick so we're all clear. Okay. We'll go ahead and get out of this and come back and hit this again. Okay, so now I have hit the breakpoint. You can see I'll make these tiny. I've hit the breakpoint. You can see in my threads window that I am on thread 14952, right? When I take a step now, that yellow instruction pointer is going to land on a different thread because it's going to hit that same breakpoint. And it landed on 6524, right? So now, even when I remove that breakpoint and take a step, I'm going to step between 6524 and 1452. But no other threads are going to be step between. So if I want to just step on one thread, I have to delete my breakpoint on the thread I stopped on. So, and I'll prove that here for you now. When I set this breakpoint, boom, breakpoint, boom, hit breakpoint, delete breakpoint, disable breakpoint, anything. So now I'm going to only stop on this one thread, and I can debug through this single thread. So hopefully that helps. So sometimes deleting or disabling breakpoints will help you debug your multi-threaded applications. And if that explanation was too complicated, you can always just use a filter breakpoint. So when I go into settings right here, I can do conditions, filter, and then by thread ID equals, and then I put the name of the thread. And you can get that name of the thread from the watch window right here. So I could do 14952. And the only caveat with this that you're going to want to remember is that the thread IDs obviously change every time you restart your debug session, or could change.
If you did breakpoint for the value equals 25,
Yes.
would it break only on that thread?
Yeah, so the question was, so if you did a conditional breakpoint for when candidate or the value equals 25, would it only break on that thread? And the answer to that question is yes, it would. So conditional breakpoints, filter breakpoints, if you know what you're looking for when multi-threaded, those come in handy. So are there any other questions about any of those multi-threaded windows that I showed you? No? Okay. Raise your hand if you've learned something new that you might not have known before. Oh, I love to see that. Yeah. Okay. So I just got to the end of my VS 2015 demos. And we talked about the multi-threaded situation. Oh, I forgot show threads and source. Whoop. Okay. The last thing, since I forgot, I just want to show. There's this button right here on the toolbar, up here at the top. Sorry if you can't see. Show threads and source. And when I click on this, it's going to do exactly what it says. We try to be smart when we name things, I promise. A lot of the product may not feel that way, but show threads and source actually does show the threads and source. So right behind this breakpoint, there's a little thread, and when you hover over it, you can see what threads are stopped on that line. And so if I were to hit continue, and my threads went somewhere else, like up here, you can see what thread is stopped on that line. So that's show threads and source. Cool. Thanks. Thanks for bearing with me, guys. I know 75 minutes is a long time, but I've been having a blast. Okay, so that's all of that stuff I showed you is in Visual Studio 2015. So what's next is your question. And since you've hung out till the end of this, you're going to get rewarded with some extra goodies. So we're going to talk about some stuff in Visual Studio 15 Preview 4. Preview 4 is what is the preview that is released right now. You can go get it on visualstudio.com. And I have it installed here on my box. So I just have, I threw together just a little silly console app just to show some of these things. And when I hit start, boom, I get an exception thrown. So this looks different than that big gray dialogue I made an effort to dig on before, right? That's because in Visual Studio 15, we've redone that exception helper. So now it's non-modal, it's inline. This works for all languages. So if you're a native developer, you're used to C++ exceptions coming up in a modal dialog you have to dismiss. That's gone. They're all in this quick non-modal window. And the best part is you have instant access to your inner exceptions. Can you see that right there? No more having to click details every time you hit an exception. We will show, if there is an inner exception, we will show it right here in the exception helper. And if there are more than one inner exception, you can navigate between these things. So I just clicked this little left arrow, and I can see the inner exception that led up. Sorry, tongue-tied. We will show you the innermost exception first. So like this says 2 of 2. So instead of having to click details and go inner exception, inner exception, inner exception, inner exception, because often it's the one at the bottom you want, we show that to you first.
So which version is this?
So VS15 is our vNext version, and that is where this is. So it's the preview version that is currently out there. Yeah. See, this is what I was like. Sometimes we try to name things smartly, and sometimes we're just like, screw it. This is how it's going to be. So yes, this is VS15, which is the vNext stuff. And I'll actually be at the expo booth after this, and I have these bits on that machine if anyone wants to come and take a look or try out some of these things if you haven't but you can also download Preview 4 and get those yourself. So yeah, so we've redone this window. We're still, since we're in preview, we're still tweaking some things out. I shouldn't have said that. We're still making some tweaks to this. And you can actually make this smaller. You can unpin it. You can dock it. You can always have your exception show up in the right corner here. So as I continue, you can see that this key value is changing. And so we've just tried to make this a little bit more friendly for you to use. So another thing I want to show you that's new in the preview, you can see that as I hit continue here, it keeps incrementing the keys. So I'm just loading settings in this example, and I'm going to hit this exception every time a key's not found. This is kind of expected, and I don't want to break on this exception every time it's thrown. So previously, I'd have to turn off just the type of exception. But in this case, it's a system.exception. That's super generic. I actually want to be notified when that happens at other places, but just not when it's happening right here in my settings library. So I can go to my exception settings window. I've searched for system.exception right here. I can right-click on this and do edit conditions. So we've added a module name condition to the exception settings. So I can exclude breaking on any exception thrown in a specific module, or I can do it for a specific type. So in this case, I'm going to do it for system.exception, and I'm going to do star settings star, just to show you that we support star-based wildcard matching. So any module name that I have that contains settings will no longer break on a system exception. And I just hit OK here. And this exception will get thrown like 50 more times, but now when I hit continue, it doesn't break anymore. Sorry, guys. That was my bad. I guess this just became a demolition instead of a demonstration. the coming soon stuff, these are hot bits. I got these from my developer right before I left for the conference, and I just barely got clearance to show you guys some new stuff that's coming soon. So shh on noticing that. I'm actually just going to restart this. Like I said, we're still working on some tweaks, and that's why this crashed. But hopefully by the time we are able to ship this to you, not hopefully, by the time we ship this to you, the quality will be improved.
Is there a date?
I cannot comment on a date. I'm so sorry. I know that everyone wants to know when these things are hitting. I can just tell you, coming soon to a theater near you. What was your question?
The name also being tweaked?
I think so. I don't think we're going to release it as VS15. That's my own corner. Don't quote me. Okay. Okay, back here. So I applied that condition to my exception. And that should have worked. But I know it does work. So I'm going to hit those exceptions again and show you what you're probably all thinking. Why do I have to come to the exception settings window to add that condition? Why can't I do it directly from where I stopped at that exception? And the answer is, we thought about that, and you can. So when I break here, I have this exception settings, and you can collapse it so it's small and out of your way. But I can break when this exception is thrown, except when thrown from mysettingslibrary.dll. So by checking that checkbox, that means that I won't break in this module anymore. Okay, you can clap. That's okay. You can be happy about it. We like making things that make you happy. So now I do know that this one works, and when I hit continue, I won't stop on those exceptions anymore. See? Now I finished. So that setting gets saved with your solution. So exception settings get saved on solution close. And so that setting gets saved with your solution. And if you want to delete that setting, you can just go to Edit Conditions and hit the X button next to that condition. Or you can click Reset, and that'll reset all of your exception settings to a clean state.
Can you do it on the line itself? That would be really cool too.
So the thing is, you can't turn them off from the line themselves, because by nature of the condition, you're no longer breaking on that line. So if you were to break on that line, we've done something wrong. So, okay, so I've got 7 minutes. You guys are with me? There's 2 more cool things that I think you're really gonna love. Okay, so these are, like I said, so that checkbox has not been released yet, but it's coming soon. The conditions is in preview 4, that first window that crashed that I can show you. And now I'm going to turn on my null reference exception. So this has been a top user voice ask for some time, and we finally got around to it. We've worked with the CLR team. And so right here, you're looking at this exception that's thrown in my exception helper, and I want you to notice that it says find container was null. Find container return null. So yeah, in this giant list, I know sometimes I'm a lazy developer, and instead of like separating all the lines out like I should to make it more readable, I'm just like ... And if you do this too, oftentimes when you encounter a null like this, you have to, these are method returns, so I have to go to the return values, I have to hover over things, I have to split this up, and that just takes a lot of time. So what we're trying to do with this feature is just instantly be able to tell you what was null. So like you clapped for, in this specific case, it's telling me find container was null, and boom, I immediately have that information. So that's going to be available coming soon to a theater near you. Question? So his question was, is that a part of the exception details? And unfortunately, it is not a part of the exception details. It's something that we're able to do as the debugger because of our communication with the CLR. So yes, and we're still working on being able to apply this null to more cases. So right now you may encounter situations where you're like, that should be telling me what's null, but we just haven't gotten to that heuristic yet to hook up that one, most likely. Okay, so that's what's null. And the last thing I want to show you is something I'm super excited about. So my question is, remember when I said at the very beginning of this talk, there will be a quiz on that later? This is the quiz. What feature was I talking about? Run to cursor, good job. I didn't think you guys would remember that. So yeah, so this quiz is on run to cursor. Right now, you have to opt into this. So go to debug options, and all the way down at the bottom, there's this checkbox that says show run to click button in editor while debugging. So once you click that option, again, this is coming soon, but you'll still have to click that option. As I'm hovering over my code, look to the very left of each line, and I'll zoom in, do the little Windows plus, and it's right here. You can see this green arrow, right? Guys, this is run to cursor. This is point and click debugging right here. I'm going to click on this. It's going to run to that for loop. I'm going to click on the bottom. It's going to run again. So this is awesome for point and click debugging when I, for instance, want to just, for loops are a pain to step through. And I could go down here, set a breakpoint, step over, but I just will forget to delete that breakpoint later. So I'm going to point and click and just run to this line of code. And it even works running between method calls, just like run to cursor does. So if I want to go into this interesting method, instead of doing the step breakpoint, step in, delete breakpoint, I'm just going to click run to cursor. And yeah, this method wasn't that interesting. Guess what? I'm going to click right here and run back. So that's run to click. So I designed that feature, and I'm actually looking for feedback on that because there are definitely, whenever you put something in the editor, there are a lot of concerns from people about, if it's too much noise, if it's giving you a headache, if you can't type something because it's there. We've done extensive user testing on it, but you have my email. If, when this coming soon, and you get your hands on it and you have any feedback, please shoot me a mail. Let me know what you like, what you don't like, or if you want it ripped out entirely, which I hope not. So before everyone leaves, and I'll let you out 1 minute early, I have another request. Like I said, I was asking for feedback. Oh yeah, coming soon. Run to click, see what's null, conditions from the exception helper. Like I said, I was asking for feedback. Well, over on the diagnostics team, we're trying to create a community of customers who are interested in our experiences or their debugging experience, their profiling experience. So I ask that you go to this link and just fill out the form with your name and email and maybe what you're interested in. You'll see when you get to that link, and it works on your phone too. But basically, this is a list that goes into my customer database where I can so what you get out of this is that I could send out an email to everyone and say, hey, we're looking for customers to interview about problem XYZ, multi-threaded debugging. And then we'll set up a 20-minute phone call. You can tell us, we'll have questions for you. You can tell us how you're using Visual Studio. Sometimes we're trying to be more experimental by giving you preview bits to let us know how this works on your applications. I did that with Run to Click with this community. So we're just trying to build that up. So I encourage you to become a part of that. And we don't spam you with emails. It's really just about trying to learn from you and trying to really customize your experiences to make sure we're doing the right things. I also have resources up here. The code from this demo is on aka.ms vsdiag samples. We've got a blog. If you want to know more about the diagnostic tools window, debugging performance issues is a great video to watch. I'll wait till some phones go down before I switch the slide. And we always blog at the diagnostics blog whenever we release a new feature. So you can follow that blog if you're interested in knowing what we've got to show you. Okay, and if there's any questions, come up, talk to me. I'll be at the booth in the expo. Follow me on Twitter, tweet it up. Thanks so much for coming, guys. Ooh, thank you. And don't forget to fill out your evaluations for me if you like me or don't like me. But if you're just meh, don't worry about it. Just kidding. Thanks. I hope you guys had fun.